today my talk is going to be a little bit different than some of the other talks that you've heard. I mean, we've heard some great projects that are being done by different people in the group here, and some of those base isolation projects I'd love to work on. They're incredible projects. But today, one of the products that should come out of this working group is really some type of publication or some type of guidance that comes. And one of the ideas that I had this summer was late in the summer I contacted Anthony Wood, started telling him some ideas I thought of proposed changes that actually could be in the updated Ctbuh guidelines. And so he said, if you feel that strongly, why don't you just help? Okay, so here I am. And one of the goals of this talk, I would hope, is that it would re-energize that effort to update the guidelines, and it would also just help to recruit people who would be willing to help out and be strong authors in this effort. Today I'm going to go through a little bit of brief history of the guideline development. We're going to talk a little about the international demand for guidance and consistency in performance-based seismic design. Talk about some of the updated resources we would have and goals for an update and examples, and these would just be examples of what I would think should go into an updated guideline. A small group of authors would actually finally decide that and prioritize that. But then talk about proposed timetable and recruit contributors. I'm going to be here all week. I've already twisted Ron Klemensik's arm, so I think Ron is going to help out again also. But, the idea would be that, my hope would be that people would come forward and talk about it and see if they were really interested in helping out. The original guidelines were produced as a result of a seismic working group that was formed in 2007. The co-chairs at that time were Ron Klemensik, Michael Wilford of ARUP, and Andrew Whitaker of SUNY Buffalo. And it implied in the guidelines a performance-based seismic design for tall buildings. Draft was published in early 2008. It was peer-reviewed, and the idea with the new guidelines, it would also be peer-reviewed by a larger group that would hopefully be an international group, and completed in August 2008 and published. Why focus on performance-based design for tall buildings versus prescriptive design rules? I mean, the idea is that you're dealing with structures that are well over 1 second in their period. So, the code and the prescribed rules are more geared to actually, like shorter period structures. Significant mass participation is in higher modes, so, and larger proportion of the drift is due to the cantilever action. So some of the interstory drift constraints and established criteria are based on shorter buildings where cantilever action is not as significant. Advantage of using performance-based design is more accurate assessment of performance. It gives you the ability to assess unique architectural features and unique projects and structures. It allows for the use of innovative systems and materials. So what we were talking about this morning in the session with supplemental damping, and here we've touched on a few cases of base isolation, and hopefully reduce construction costs. Disadvantages of using a performance-based system, design versus prescriptive design rules. Design team requires extensive knowledge of current practices. Sometimes the rules are not well defined, and the protocol for review is not always clear. Disadvantages, some more disadvantages is more labor intensive and requires more time to complete, and it is a more extensive review. So, these need to be taken into account in the schedule. Performance-based design should be an alternate or an additional analysis and design. International standards are moving away from, or moving towards having performance-based design for tall buildings as an alternate design method. Prescriptive local design rules and protocol are well established, and recommendations should be framed to offer it up as an alternate design, in my opinion. But approval authorities still have to decide. So obviously you're dealing in places where the protocol and prescribed methods are very well defined. You can't mandate something like this. increased demand for guidance and consistency in performance-based design. It's a rapidly developing field. So, U.S. has significant projects now completed. There's a few projects on the West Coast that now have been completed. In China, the level of documentation has substantially increased. Most of my experience is actually with performance-based design working in China. And compared to what I had to document 8 years ago for a expert panel review compared to now, there's a lot more documentation that's actually included. And then I'm also a member of the Earthquake Engineering Advisory Group for Ctbuh, which is the British licensing exam. And in Ctbuh, they're looking at trying to get that institution more involved in international work. And that institution has a number of members who are coming from China now and are looking to be licensed as Ctbuh. So Ctbuh actually sees that the influence of having more Chinese members is actually going to be pushing their ability to actually, it's going to be necessitating them to learn and to actually be more involved in earthquake engineering internationally. And there's common ties in international groups looking for design guidance. And what I would say is Ctbuh is uniquely positioned to provide design guidance for performance-based design as it relates to tall buildings. Some of the more recent updates that exist now that didn't when the first guidelines were published. The first guidelines were published in 2008, and there's good general discussion on topics, but at some point they would bring up items that actually should be considered but didn't give a lot of design guidance of how they should be. In 2009, NIST published a report that was research required for support of full implementation of performance-based seismic design. And this document was used to produce a number of additional studies, one of which is ATC 72 document, which details analysis modeling that actually should be analysis rules and guidance for performance-based design. The peer document was published in 2010, and this is a pretty extensive document that gives guidelines for performance-based design of tall buildings. And this document is referenced by other documents too that have been updated. And then also in 2011, a design guidance was given for selection of seismic input. So giving some design guidance on picking time history records and getting the input right for time histories. Additionally, in 2013, ASC 41 was published, which was an updated version of that code. And in that code, there's a lot of guidance given for component performance objectives. And that's a code that's actually been referenced, I've seen in some of the work we've actually been working on in China. But probably the best and latest document that's come out there has been a 2014 publication that's come from the Los Angeles Tall Building Group. And this is an affiliate member of Ctbuh, and it's an alternate design procedure. The design guidance is good because it's based on the latest resources. It's a succinct design publication, so it's only about 50 pages, but it's geared to designers, and it's meant to be kept brief and with good design guidance. Its focus is for designers. Practical simplifications are given for modeling. And one of the questions, the goals for the update should be an update or a rewrite of the current recommendations. And I think that's to be determined. Depending on who the authors are and how many are in the group, we'd actually make an assessment of whether or not we should be updating or completely rewriting. The final decision will be made by that group. But in order to make the document useful, a different flow may be required. The audience for the update, one of the ideas would be, obviously structural engineers who are doing performance-based design work, structural engineers with tall building experience, architects who are working on these type of projects, maybe approval authorities and reviewers, and even clients, so that they had an idea about how this type of work and design work actually influences schedule. Focus recommendations should be on tall buildings. Performance-based design is used for all types of buildings, but the design guidance that we're going to be offering is really going to be focused on tall buildings. And define when this type of design is required. So most codes have some type of height limits that they require an over limit definition. This code, I think, in any kind of guide that we publish should also go into that and actually give a recommendation on when they think the recommendation should be used. And present as an alternate procedure, but allow recommendations to be referenced as additional measures. Update it to reflect the current best practice. And one of the other goals I thought was educate tall building experts with limited performance-based seismic design. So the idea is to try to bring in a whole group of people who haven't been doing a lot of work in this field. For instance, Ctbuh, I know, is full of, one of the ideas that that organization has is actually issuing a publication like this as well. And then provide rules for consistency in performance-based seismic design analysis and reporting of results. So one of the ideas that you have is that so much data is actually created when you do this type of work, that one of the things that you need to be able to do is provide some guidance on consistent assumptions that should be made. And distinguish between performance-based seismic design and prescriptive rules. So some prescriptive checks still come in and in the design process, and the idea would be to try to define those and really distinguish those from true performance-based design. And add figures and illustrations, just make things easier to describe. Establish also a format for the design criteria and suggest maybe ways that criteria could be presented in a report. And then also provide guidance for analysis modeling. Provide guidance on protocol for analysis and design review, and provide guidance on reporting of results. So, you know, when you're going through and doing this type of documentation, as we said, it's a large amount of volume of work. Give some idea about, some guidance about what elements should actually be shown and documented. Examples of possible updates. One of the ideas I had was just the idea that you, in many of the publications, define performance-based design as just two-phased, and this is consistent with the Chinese approach too, with the expert panel review and over-limit design, is a service level earthquake that's a linear elastic analysis and design that can be done by response spectrum with time history. And then design checks are using local capacity calculations. Performance-based design then usually has a second level of analysis and design that takes into account the rare or maximum credible earthquake loading and nonlinear time history analysis, where you either define deformation-controlled elements or force-controlled elements, and then between those, even critical or non-critical elements. And you know, just an example, this is pulled from performance objectives that were presented for global behavior, and this might be an example of a format that we could show in the report. And then taking that to the component level, where you distinguish between force-controlled actions and deformation-controlled actions, and reference different guidelines that are used for that. ASC 41, for instance, has a lot of material about deformation-controlled actions, so for link beams or elements that are dissipating a lot of energy. And then this is a possible format. This is like a format that we also have produced before for expert panel reports. And when you're dealing with creating and modeling, analysis modeling for nonlinear analysis, you're dealing with expected values for material are utilized. So an idea about formatting that and setting that up as a more defined set of material properties. Talk a little bit about how backbone curves are created and put this into the publication to give some more design guidance and how they might be modified to take into account cyclical loading. And then address some of the issues that always require judgment calls by structural engineers. This would be, for instance, soil structure interaction, how that should be taken into account in the design, and then also how the backstay effect should be taken into account in analysis, modeling, and design. And typically, from some of the other recommendations, in particular the newer performance-based seismic design analysis, they recommend bracketing the answer to take into account the backstay effect, and bracketing the answer by changing stiffness on the diaphragms. Also, what's come up in some of the talks today has been the issue of damping, and what's the appropriate level of inherent damping to be included in the nonlinear analysis. And so there are some provisions and some guidance given for that in ATC 72, and some of those documents we've actually been referencing in our work already. And then also get into the idea about how areas that are strengthened zones should actually be modeled to ensure that we're getting the appropriate behavior. This is traditionally, when you're dealing with outrigger systems, you always have large localized panel forces. And so just the idea about, setting up a criteria for modeling that so that you can actually appropriately model and get the appropriate loads into the embedded steel. And one of the issues is, of course, with any type of analysis that you're doing in this high seismic zone is getting the input correct. So the publication that has been published by NIST gives a lot of information and a lot of direction on selecting and scaling appropriate time histories. So look at that and look at describing what would be the basis for spectral matching or scaling of time histories, and also provide clear direction on application of time histories, frequent and also rare, and when direction actually makes a difference or it doesn't for near field events. Provide guidance on reporting of results. When you're talking about nonlinear time history analysis, you're talking about time history analysis where you're dealing with a 0.02 second time step, usually something on that order. And when you've gone through a whole record, you basically have 2,000 different results on every single element in the structure. So some idea about giving idea about how those results should be formatted and presented. And also some direction on clear design criteria that should be used. And what's the appropriate level of documentation that should be given for frequent level checks and also rare level checks. And it's a major undertaking, but in most of these conditions, case studies really do help as well. So the idea might be to supplement this work with case studies that would show how the guidelines should be actually provided or applied and appropriate. Then provide guidance on review process. The review process is very well established here in China already, but the idea would be that, in some of the documents that have been published recently, they give some guidance on what would be the minimum number of people who should be involved in the peer review process. And of course, like an idea about having some guidance on at least a geotechnical engineer who would deal with the seismic input, a structural engineer with expertise in the field, and then also maybe a researcher or an expert who has expertise in this particular system that's being proposed. Provide guidance on the design process, and this might be something that would be really useful to, in particular, clients, so they understand how it impacts the concept design schedule and schematic design schedule, and when criteria should actually be presented to experts for peer review and when not. And also in the design development, what should be produced as far as the performance-based seismic design report, like when that should occur in that schedule. And then the follow-through of that, like how that then is realized and how any of the comments from the experts or peer reviewers are realized through the whole process. One of the issues with review is also the idea about engineer of record has a certain responsibility, but also the reviewers to be accountable for having a review process where they bring up more broad items and the review becomes more detailed as the process goes along. because there is such amount of analysis and design work that's required, and it's very labor intensive. The idea that you could go backwards and start with a more fundamental question too late in the process can have a really negative impact on the project. And then presentation, final report, and results, an idea about how that should be presented and what it should look like. Some of the ideas for a timetable, and this is pretty aggressive, but the idea is that we're kicking this off right now during the conference and the workshop right now. The idea would be through November, maybe establishing a group of primary authors. In December, the authors would prepare for a meeting at Ctbuh in Chicago, or by video conference in their office in Shanghai, I guess now, and draft initial outlines. In January, we'd have that initial meeting. And these are just initial drafts that I put on a schedule, hopefully with a publish for peer review in August 2015. Review comments back in October, and the publishing of the updated guidelines in December 2015. But all this schedule would be coordinated with the primary authors when that meeting occurs. So last thing I'd talk about is recruiting contributors. The peer review process will be extensive. There'll be a group of 20 that will be selected by Ctbuh and international, have all influences from design all around the world. The primary authors must devote significant amount of time to the effort. There's a lot of work that's going to be involved in this, and so what we're going to solicit is people who aren't just going to, be doing a review process. There'll be people who are actually really producing work, and primary authors should complement each other's background. We're looking for structural engineers with performance-based seismic design experience, tall building experience, and international building experience, and geotechnical experts. And finally, I would just say, if you're interested in being involved in this process, you can reach out to either myself or Ron Klemenczyk for more information. So anyway, thank you.